Konnichiwa friends, my name is Asman Samasi and welcome to day 4 of the 100 days of deep learning practice session. Okay, in this video we are going to practice our neural networks plus our activation function inside an torch class. Okay, remember that if you don't understand anything, you could go back to our PDF and check all theories again. Okay, and you could also use internet or chat GPT. Okay, and solve 5 problems of same time to get a fair idea of how it works. Okay, so let's start. Here the first question is we have to create a neural network with first in linear layer, then our ReLU, and then our linear again. Okay, so first I have to import our torch and our torch.neural network. Okay, torch.nn as nn. Okay, so this will import our neural network. Okay, and our torch function. Now here, okay, for our class net A, we will be creating a class named net A, which will use our nn module, which will have here two function here. One is init, one second, which will take here self, and then we will call our super dot init, and then we will define our first linear layer, which will be our 4 to 8. Then our second linear layer, which is our nn.linear 8 to 12, 8 to 2. Okay, and then our activation function. Okay, which is our ReLU. Okay, and here we make our forward function, which will take our self and x, and then we will pass it one by one. Okay, so I will be first passing x with our f1, then our activation function, and then our f2 function here. Okay, and then we will return it. Okay, and let's print our net A class. Okay, you will see here that the class is complete. Okay, also you could check the answer from here. Okay, so here the everything is done here with the entire same format, just that here the variable names will be different. Okay, also it is better to use is that first declare all neural networks and then our activation function. Okay, like this will be very good. And also check how basically the x is flowing from one activation function to other. Okay, So this would be also the case. Now we have to create a netb class with our nn.module, which will have our //init, which will take self, and here we will first call our super dot init here, and then we create our first neural network as our, it's a linear, so we write it L1, which is nn.linear 10 to 20, and then our ReLU function, which is our nn.ReLU, okay. And then we make our forward function, which take our self and x. Here we pass it directly using self dot L1 x, then we will be putting into bracket and closing it completely with our activation function, okay. And we will be return this x. When we print it, we will see our netb here, okay. Here, so here this class is also sorted, okay. Now here we have to make a new function name netc, okay. So here we write netc, which will take our nn module. It will have two functions here. First is our init, which will take self here, and here we will first call our super dot //init / and then we will be calling our, okay, then we will be calling our first linear layer, which is nn.linear, okay, 6 to 12, and then there's another layer that is going from 12 to 6, okay. And then there's an activation function here, acc equals to nn.ReLU, okay. Then our forward function, which take our self and x, which will return, what did happen, which will return our self dot fc2 at last, then our self dot ac, then our self dot f1, okay. So I return it directly, okay. Here it should be x, and we will be printing it and getting the value, okay. For netc we get this, okay. Now for here d, here it is saying to create a netd function, netd, which will take from nn module. It will have your first dev.init, that will be taking self, then our super dot init, and then here we basically here now use sigmoid, okay. Sigmoid here for our first here, when we do here def first self dot f1 equals to nn dot linear going from 8 to 16, then our second here we have many activation function and our linear, so we will do it one by one. Okay, we write here sigmoid equals to nn.Sigmoid function, sigmoid activation function, then our f2 equals nn.Linear which will be going from 16 to 32, then our finally ReLU function. Okay, ReLU which will be going from linear 32, no, it's in ReLU function now, ReLU, and then our L3 which is our nn dot linear going from 32 to 4, then we use our def forward here self dot x, we will be passing through our first layer. Okay, x equals to self f1 x, then our self sigma, then our f2, and then our ReLU, then our f3, and then finally returning it. Okay, so here now if we will print our netd here, we will see the final functions. Okay, here okay, so now we will be going to our netd which is asking to use our sequential. Okay, so now we will make a new class with nn.module, then our first init function which takes our self here, and then we call our super init here, and then we had to make an sequential layer. Okay, so we will write it nn.Sequential, and here we will be passing our directly. Okay, so first we have our linear layer going from 5 to 10, then our ReLU function, and then our linear layer going from 10 to 1. Okay, then we make our forward function here which takes self and x, we pass the self dot sequential directly. Okay, par is sequential x, then print the net e. Okay, and nn. Okay, so you will finally see this. Okay, now it's clear. Now we have net f here, we will use the same nn.module which is with our first our def init, which will take our self here, then our super slash init, then we make our sequential layer only. Okay, so self dot sequential equals to nn.Sequential, and then we first pass our linear layer from 20 to 50, then our ReLU here, and then our nn.linear here. Okay, then forward we write here self and x here, and now we will be returning the whole sequential layer. Okay, sequential of x, then we will be printing the net f here. So finally we get the output. Okay, now we have here net g here, which also have linear then ReLU then linear then ReLU then linear. Okay, so let's swap it by our Tanh function. Okay, so we will write here Tanh function, and so yeah, let's see if we could do it or not. Okay, although the ReLU is most common, it is important to practice our other functions too. Okay, so we will write here self, then our super class calling, initialization of our super class, then we use our sequential layer only. Okay, so we will write here nn.Sequential, we will be passing first our linear layer from 3 to 6, then our ReLU, then our linear 6,9, then our Tanh function, then our linear layer again. Okay, 9 to 3, then we use our forward. Okay, which will take here self and x here, then we will be returning the whole sequential layer. Okay, self dot sequential layer x, when we will be printing it, we will be getting the output here. Okay, I think the Tanh function is wrong. Okay, so finally this is what we got here. Okay, in our net g here, now we have to create a net h here, class net h, which will be importing first our nn module, then our init function, which will take here self, then we initialize our super class, then we use your sequential layer only, nn.Sequential, and we'll be passing linear from 784 to 128. Okay, nn.ReLU, then our nn.Linear. Now let's change the question and think that this may be an classification problem. Activation function, okay. Now you tell me that what is that classification function, okay, please. So if you have guessed it correctly, it is the nn.Sigmoid, okay. nn.Sigmoid. As you know that here in where to use, I have told that activation function is always followed after a neural network, okay. So here an neural network complete, then an activation function, then another neural network, then an activation function. Here if it's in regression task, we would have used here nn.Linear and cutted it, okay. But here since it's asks an classification activation function, we will use here either Sigmoid or our softmax, okay. So here we use our Sigmoid for binary class classification, okay. So after we write it, we write directly here, okay, x, and we return here self.sequential, print our nth. So finally it's done, okay. Now I here we will write here class net I nn.module it will be our regression problem. So we make here our init one, which should take self here, then we initialize our super class, then we make an sequential layer, okay. Now directly nn.Sequential, and we first pass here linear, that will be taking 100-dimensional tensor returning 64. Now we have here ReLU function, then we have here nn.Linear, which is going from 64 to 32 with the same. Then we have our ReLU again, then our linear layer, which is from 32 to 10, okay. Then here since it's a regression problem, we will do our linear 10 to 1, okay. So it will give us one-dimensional value, okay, and that is important. We could also use nn.Flatten before it, okay. So like it could directly flatten the whole tensor here, okay, but it's recommend not to use it because we always use our nn.linear x to 1 for our regression problem, okay? And here we return our sequential directly, okay? X, and finally printing net I here, and you get this value, okay? Now here make it an multi-class classification problem, okay? Now what should be our format? We will have our class netj with nn.module here, then we have our self, then we have our def init, which will take our self, and then we will initialize our super class here, init. Then we make a sequential layer here, nn.Sequential, nn.linear, which is going from 16 to 32. Then we have our nn.batch normalization, one dimensional, which will be taking our 32 batches. Then our ReLU function, then we have our linear going from 32 to 8 here. Since it's a multi-class classification problem, we will use here nn.softmax, okay? Now finally we are making our def forward with our self x, and here we will be returning the whole sequential layer, okay? So self.sequential x, and then we will be printing it netj. So here finally you will see the final one, okay? So here basically the other questions are left out for you as an homework, okay? So please do it, and the answer you could check from here, okay? So here if you will click this, you will get the, I think it should be answers, okay? So here by going to the notebook you could get all your answers, okay? So you could check it thoroughly, okay? So I will update this by now only. So yeah, that's all for today, and happy practicing, okay? You could also check the whole PDF of the day 3 and day 4 to get more clear about the activation function and the neural network, okay? And believe me, it's important for our tomorrow's lecture to practice it, okay? So that's all for today. Bye bye.